Hello friends, previously we have seen what is the trigonometric equation and what are the solutions of trigonometric equations. We have also seen that solutions of trigonometric equations are divided in two parts, principal solution and general solution. So today we are going to see how to find out principal solutions of some trigonometric equations. Let's start with this example number 1. Sec theta equal to 2 upon root 3. If we want to find out principal values of theta, it means the values of theta in between 0 to 360 degree. Okay. Then first of all we will convert this sec by taking its reciprocal into cos. So while writing the solution, the first step will be like I am going to take reciprocal of sec theta, that reciprocal is cos theta, and obviously reciprocal of 2 upon root 3 is root 3 upon 2. Okay, now initially when this particular value of right side is positive, then it is easy to find out the first value of theta, which obviously lies in the first quadrant. Okay, with the help of this particular table, we all know that cos of 30 degree is root 3 upon 2. Therefore, we can say the first value of theta is 30 degree, that is pi upon 6. We can check out this value from this table. Okay, so how can we write? We write it as cos of 30. 30 means pi by 6 is equal to root 3 by 2. Okay, theta is equal to, we can say, pi upon 6. So this is our first solution. See, when the value of particular ratio is positive, then we always get the first solution in first quadrant because they are all positive. Okay, then we will call that particular angle as theta, which is the solution pi by 6. Now we will see, other than first quadrant, in which quadrant that particular ratio, means in this case cos ratio, is positive. For that we need this particular data, all S, T and C. We all are familiar with this particular thing. This shows that our cos is positive in fourth quadrant. It means our next value of theta lies in fourth quadrant. Now if the angle in first quadrant is theta, then we write next angle in second quadrant is pi minus theta, in third quadrant it is pi plus theta, and in fourth quadrant it is 2 pi minus theta. Okay, so now in this case, as we are saying, value of cos is positive in fourth quadrant, next positive value is in fourth quadrant. So we are going to write the allied angle formula using cos of 2 pi minus theta. Write down the allied angle formula 2 pi minus theta for the ratio cos. Okay, so it is equal to cos theta, because remember 2 pi minus theta means fourth quadrant, and fourth quadrant cos is positive, so it is plus cos theta. Now replace theta, theta means pi by 6 in this particular equation. So you can write here, put theta equal to pi by 6. Pi by 6 is one of the solution, and we are going to use that value. So cos of 2 pi minus pi by 6 is equal to cos of pi by 6. I am replacing theta is pi by 6, theta is pi by 6. Now solve both the sides simultaneously at the same time. Therefore we get cos of, what is 2 pi minus pi by 6? 6 into 2 pi, 12 pi. 12 pi minus pi, that is 11 pi. 11 pi upon 6, and which is equal to cos pi by 6. Now remember cos pi by 6 is root 3 by 2. So you can write it as root 3 by 2. So this implies what? We get the angle 11 pi by 6 such that its cos ratio is root 3 upon 2. See, so cos theta equal to root 3 by 2. It means in this case theta equal to 11 pi upon 6. Okay, and this is our second solution. Okay, so our principal solutions are, therefore our principal solutions are pi by 6 and 11 pi by 6. Remember, while solving these examples for principal solution, we always making the use of the value in first quadrant. and we will find the next value either in the second, third or fourth quadrant, wherever it lies. Let us solve our next example. Cot theta is equal to root 3. Remember, convert these cot, sec and cosec by taking its reciprocals into tan, then cos and sine. Okay, if you take reciprocals of these terms, they will convert into tan, cos and sine. Using these values, sine, cos and tan, we can find out their principal solutions. Okay, so let's see here. Solution: cot theta, we can write it as, by taking reciprocals, cot theta, it becomes tan theta, and reciprocal of root 3 is 1 upon root 3. So we are actually going to find out the solution of tan theta equal to 1 upon root 3. We all know tan 30 is 1 upon root 3. So we can write it as tan 30 means pi by 6 is equal to 1 upon root 3. And therefore our first value of theta is pi upon 6, which lies in first quadrant. Now see, 1 upon root 3 is actually positive value. It means we get values of theta in the quadrant where tan is positive. The values of theta are in first quadrant and in third quadrant, because in these two quadrants tan is positive. So in first quadrant we get the value theta equal to pi upon 6. Let us find out the value for third quadrant, where we can write the allied angle formula for pi plus theta. So we can write using tan of pi plus theta, it is equal to tan theta. Remember, in third quadrant tan is positive, so it is plus tan theta, and pi means there is no change in the ratio. Okay, so I'm going to substitute now theta equal to pi by 6. Okay, so I'm going to write like tan of pi plus pi by 6 is equal to tan of pi by 6. Okay, therefore we can say tan of 6 pi plus pi, it is 7 pi by 6, which is equal to tan pi by 6, but tan pi by 6 is 1 upon root 3. So it means what? Tan of 7 pi by 6 is also 1 upon root 3, and therefore you can say theta equal to 7 pi by 6. So this is the another value of theta, and therefore the principal values of theta are pi by 6 and 7 pi by 6. That's all. Let's move to our third example. It is cos theta equal to 0. Now solution: if you convert this into tan theta, it will be tan theta equal to 1 upon 0, which is not defined. So we all know cot theta is 0 and tan theta is not defined. At which angle this happens? So we all know when theta equal to 90 degree, okay, cot theta equal to 0 or tan theta equal to, you can say, not defined, infinity. Okay, so we can say the first value. Now this value of theta is not in any of the quadrant, it is on the axis. Actually it is on the y-axis. Cot of pi by 2 is equal to 0, and therefore theta equal to pi by 2. Now observe that value of cot is 0 at the angle of 90 degree. It means on y-axis. It will be also 0 on the negative side of y-axis, where 3 pi by 2 lies. So we can write cot pi plus theta. Theta means what? You can write pi by 2. So which is nothing but cot of 3 pi by 2. And at that value of cot is also 0. So you can write theta equal to 3 pi by 2. And therefore our principal values of theta are pi by 2 and 3 pi by 2. This one is very easy. We all know the value of cot is 0 on y-axis. Therefore value of theta is 90 degree at the positive side of y-axis, and which is 270 degree, that is 3 pi by 2 at the negative side of y-axis. Therefore these are the values of theta. Now let us move to our next example, where the value of this trigonometric function tan theta equal to -1. Let us write down its solution. Now here I am going to consider the value of theta, where its value of tan is actually +1. So I am going to write as tan of pi by 4 is equal to 1. So I am going to call that angle, say suppose x. Now x is equal to pi by 4. Now see, I'm not going to take that value as theta because it is not the solution. So here I'm going to call that angle pi by 4 with some another variable, say suppose x. Okay, because that pi by 4 is not actually the solution, so we cannot call it as a theta. Now I'm going to write two different allied angle formulae for the second quadrant and fourth quadrant. Okay, so see, using I'm going to use this particular variable x, tan of pi minus x. Okay, now instead of theta, I'm going to use the variable x. It is equal to minus tan x and tan of 2 pi minus theta. So instead of theta, I'm going to write x. Tan of 2 pi minus x is equal to minus tan x. Why? Because in second quadrant tan is negative, so it is minus tan x. In fourth quadrant tan is negative, so it is minus tan x. Now there will be two different calculations for two different quadrants. Okay, let us calculate. Now put x is equal to pi by 4. Okay, so you will get tan of pi minus pi by 4 is equal to minus tan of pi by 4. Okay, therefore you can say 4 pi minus 5, that is 3 pi. Tan of 3 pi by 4 is equal to minus sign, and tan of pi by 4 means 1, so it is minus 1. Now see, tan of 3 pi by 4 is equal to minus 1. Compare this with tan theta equal to minus 1. It means theta is equal to 3 pi by 4. So theta equal to 3 pi by 4. We got such angle 3 pi by 4 where value of tan is negative 1. Okay, so see, similarly I am going to calculate here tan of 2 pi minus x. X means pi by 4, which is equal to minus tan of pi by 4. Now obviously minus sign as it is, tan of pi by 4 means 1, so it will be minus 1. What is the left hand side? Tan of 2 pi minus pi by 4. So 4 into 2, 8 pi, 8 pi minus pi, it is 7 pi by 4. So tan of 7 pi by 4 is also minus 1. It means theta is equal to 7 pi by 4. So our principal values are 3 pi by 4 and 7 pi by 4. This is our final answer. Okay, let us solve one more example. See, this is the next example where root 3 cosec theta plus 2 equal to 0. So let me simplify this value. Root 3 cosec theta is equal to minus 2. Therefore, we can write cosec theta is equal to minus 2 upon root 3. Okay, so we have to find out actually the value of this particular trigonometric equation. But further, I'm going to convert this cosec theta by taking its reciprocal into sine theta. So reciprocal of cosec theta is sine theta, and reciprocal of this minus 2 upon root 3 is root 3 upon 2. And let me write here minus sign, so it is minus root 3 upon 2. So I'm going to solve actually this equation, sine theta equal to minus root 3 upon 2. Okay, now recall this particular situation where all STC is written here. Okay, in which two quadrant sign is negative? Remember, first and second quadrant sign is positive. So now our answer is in third and fourth quadrant where sign is negative. So I'm going to write here theta, pi minus theta, pi plus theta, and 2 pi minus theta. In third quadrant, we are going to write the allied angle formula for pi plus theta with sine ratio, and in fourth quadrant 2 pi minus theta with sine ratio. Initially, you are going to consider this positive value root 3 pi by 2. Now we can say as sine of what? Pi by 3. See, sine of 60 degree is root 3 by 2. So therefore we let x is equal to pi by 3, that is sine of 60. See, we are going to consider the value root 3 by 2, positive value, and at that positive value we are going to find out the angle. We call it as x, root, it is pi by 3. Now with the help of this x, we are going to solve further. In third quadrant and fourth quadrant, sine is negative, so we are going to write two allied angle formulae for sine in third quadrant and fourth quadrant. For third quadrant, we write pi plus theta. So sine pi plus theta is equal to minus sine theta, and sine 2 pi minus theta is also minus sine theta. Okay. Instead of theta, we can say x. So we can write sine of pi plus x. So we are saying that particular angle as x. because we cannot call it as a theta. Okay, because theta is solution here. So let us call it as x. So you can write minus sine x. Okay, and sine of 2 pi minus x is equal to minus sine x. So now just substitute value of x as pi by 3. See, sine of pi plus pi by 3 is equal to minus sine of pi by 3. So therefore, sine of pi plus pi by 3, 3 pi plus pi, that is 4 pi upon 3, which is minus sine pi by 3. Pi by 3 means what? Sine pi by 3 is root 3 by 2, so minus root 3 by 2, and therefore theta is equal to 4 pi upon 3. That is the solution. Similarly, here sine of 2 pi minus x, x is pi by 3, which is minus sine of pi by 3. So sine of 6 pi minus 5 means 5 pi upon 3 is equal to minus sine pi by 3 is root 3 by 2. So minus root 3 by 2. And therefore here theta is equal to 5 pi by 3, because at this angle value becomes minus root 3 upon 2. So this is the required value of sine for these two particular angles. So our principal solutions are 4 pi by 3 and 5 pi by 3. Got it? So this is how we are going to calculate the principal values of any trigonometric equation where that value may be positive or may be negative. Okay, you just consider the particular value in first quadrant and use that value for the rest of the quadrant. Okay, that's all for today. Thank you.